Take a close look at that. That's a compass. This interacts with the magnetic field of the Earth to help us people who get lost easily to find our ways. The magnetic field of the Earth is not negligible for us. We must consider it. All right, no problem. No problem. All right, so let's take a step back. And let's see here. Let's look at this once again. All right, so same thing as before. We have our weight. We have our weight going down. And then we're going to put a current in the bottom one. We'll call it I1. Same current I1 in the top one. All right, so that'll produce a magnetic field curling this way, which will produce the force going up, just like before. Just like before. All right, so far so good. But now, we must consider the magnetic field of the Earth. So we can pick a direction. Only the Z component of the magnetic field of the Earth is going to produce a force that would influence this equilibrium. So we have to decide, is it going into the board? Is it going out of the board? It doesn't matter. Let's just pick going into the board. All right. So let's see here. So what additional force? Take my index finger, put it in the direction of the current. This time the middle finger now is going into the board. My thumb is now going down. Oh, interesting. So this third force here is going down. So now let's look at this equilibrium equation again. Same as before, but now I have to subtract the force produced from the magnetic field of the Earth. I1 L V E Z. Z component of the magnetic field of the Earth. Okay. All right, so now here comes the trick. We're going to reverse the directions of the currents in the top and bottom wires. All right, so let's take a step back for a second. Okay, so once again, the weight. Good. All right, let's just confirm that the force from the bottom wire is still up. All right, so the current's going this way in the bottom wire. So now the magnetic field is going into the board, hence the crosses. All right, so now I2 going this way. My middle finger is now going going into the board, and upward still. Great. So here we go. All right, so now the magnetic field of the Earth won't change direction, as it still crosses. All right, so now let's see how that affects the top wire. Index finger, the direction of the current. Middle finger going into the board still, and then upward now. Upward now is the force produced from the magnetic field of the Earth. So here in the equilibrium equation, I have to add I2 L B E Z. I2. All right. So now, if you take these two equations, these simultaneous equations, and you use algebra, you get these. Oh, take a close look at these. Oh, an expression for the magnetic field of the Earth in the Z direction, or Z component. Interesting. Let's leave that alone for a little while. Let's focus on this. Okay, so look. It's very similar to what we had before when we thought we were in business. But a slight difference this time. Instead of I squared, it's the product of I1 and I2. But everything else is the same as before. Okay, so the same strategy now. We'll plot a series of different weights. And then we'll have to do 2 trials per weight. We'll have to restore it back to equilibrium to find one current, I1. And then we'll have to restore it back to equilibrium a second time to find I2, a second current. And the product of those will be the abscissa. Plot it, get our slope, mu naught over 2 pi L over R. This. Alright, so now look, some more, a little bit of algebra, Alright. So mu naught over 2 pi is the slope times R over L. Divide both sides by 2 to get what we want. The permeability, mu naught for 4 pi is slope RL. So we need 3 pieces here. We need the slope, the R, and the L. Let's grab the slope first. Let's see how we find the slope first, and then we'll revisit these later.